Welcome to Module 2, which is on basic statistics. This is going to build off of the knowledge you learned from Module 1. Now specifically what you're going to learn in this workshop is we're going to go into more details about specific statistical techniques such as correlations, mean scores, standard deviations, t-tests, and p-values. And you're going to be able to apply these statistical techniques to your research papers or to evaluate research papers. In some cases, you might even be able to apply these techniques to your job depending on what you do. Now, it's important to use statistics not only to measure results, but to create reliable and valid instruments, which is a requirement for most research and evaluation of training programs, marketing programs, etc. So the objectives for this class is going to be two, as you see in the middle of the page. First, we're going to define 5 statistical terms, and we're going to provide examples how each of the 5 terms can be used in a real-life context, such as a training evaluation. If you look at the outline, you'll see you're actually going to leave this training video for a while and head to a different workshop. Then you're going to come back and have 2 more practice sessions to fully integrate not only the knowledge but so that you have skills. So before you proceed any further, you're going to go to this URL below. Okay, this workshop that you're going to is a separate entity. You can use Chrome, Firefox, or Explorer as your browser. These are going to be websites. There are videos and other linked materials in this workshop. And one thing that you should know, though, is this online workshop was originally designed for a training evaluation context. However, the information is on statistics, and it applies to a research situation as well. And since most of you have participated in some type of educational workshop, whether it be at school or work, it'll help you understand, I think, statistical techniques more effectively because you understand what a training context looks like. Now, after you visit the workshop and view it in its entirety, you want to do it in its entirety. Don't be a slacker, because otherwise you're going to have a hard time with the quiz. You want to return to this workbook and start on the next page in order to participate in practice sessions to go over materials that were in the workshop. So you're going to stop the video now and you're going to go to this link, which will pull up this workshop, and you can see there's different web pages and stuff that you're going to have to go through. There's videos in there, and there's 10 screens in this particular workshop. And once you're done with this, then you're going to come back to this workbook. Okay? So stop the video now. At this point, you should have gone through the entire online website workshop for Module 2. Now, what I would recommend doing is you have 1 or 2 options. You can stop the video again and go ahead and answer each of these aspects here. You can see wherever there's a box, I need you to answer. So, for example, it says here a correlation. Without looking at your notes, write down the definition of correlation. So if you want to stop the video and go ahead and answer all of practice 1 with the different questions, you can do that and then come back and have the debrief, or you can work as we go step by step. But I encourage you, highly encourage you, to not just go and watch the video. I mean, you want to stop the video, answer the question, and then hear the answer in order to test yourself to see if you're on the right track of understanding this material. So if you're going to stop the video now to answer all of them, go ahead and do so. Otherwise, I'm going to start with the debrief on page 3 of the workbook, and I'll periodically tell you, if you're working with me as we go through this, when to stop the video to put in your answer. So right now we're going to start with a correlation, and go ahead and write down the definition of a correlation. Don't look at notes or anything, just try to go with your what you recall. And so if you need time to stop the video, go ahead, and then I'm going to go ahead and tell the answer. Okay, a correlation is the relationship between two variables. So you can have, like we talked in the last module, one variable could be exercise, the other could be blood pressure. You could be looking at a relationship between marriage and money problems. That would be two variables, and you can correlate those variables. So a correlation is the relationship between two variables. Okay, so now for the first exercise, I want you to look at the correlational box here, and I want you to write your answer down here, everything you know about what is going on in this correlational output box. So if you need time to stop the video, do so now. Otherwise, I'm going to go through and explain the different items you should have picked out based on this correlational output box. So the first thing you'll see is that the correlation is a negative 0.924. So negative means that it's an inverse relationship. As one variable goes up, the other goes down. So in this case, we're looking at the two variables of blood pressure and exercise. So as blood pressure goes up, exercise goes down, or vice versa. So as the more you exercise, the lower your blood pressure. The fact that it's a 0.92 means that it's a high correlation. Remember, a correlation goes from a positive 1.0 to a negative 1.0 with 0 in the center. So anything close to the 0 is a lower correlation. Anything closer to the 1s, regardless if it's positive 1 or negative 1, is a higher correlation. So in this case, that 0.92 suggests a very high correlation. The negative sign has nothing to do with whether it's high or low. It's simply indicating the direction that the two variables are going in. So a positive correlation, if that negative sign wasn't there, if it was a positive correlation, that would mean that as blood pressure went up, exercise would go up. But because it's not a positive correlation, it's a negative correlation, that means that there's an inverse relationship. As one variable goes up, the other goes down. The other thing you may notice is these little asterisks here. When you do an SPSS output, it typically indicates whether the statistical output is statistically significant or not. So in this case, it is statistically significant. And we can see based on the two-tail test here, 0.001 is less than 0.05. And so it's deemed as statistically significant. We also see that there were only 8 subjects that were used to run this correlation. So those would be the things that you should have in your answer box, that we got a negative correlation, the correlation is high, and it's statistically significant. So let's go back to the next page. So without looking at your notes, write down the definition of the mean. If you need to stop the video, do so now. Otherwise, I am going to go ahead and discuss the answer. So the mean is the average obtained from a group of scores. Now, remember there's the mean, and then there's also the median and the mode. Remember, the mode is the most frequent score that occurs, and the median is the 50th percentile. So all three are averages, but the mean, the median, the mode are a little different, as you learned in that workshop. So here it's asking you to examine the output box below and write down the mean for blood pressure and for exercise. So go ahead and stop the video if you haven't done this and determine what the mean score is for each, and then I'm going to go ahead and talk about the answer. So if you look at the output box, you see that blood pressure, the mean score is 10.125, or if you raise it up, it's 10.13, and exercise is 11.25, or if you raise that up, it's 11.3. So that is the mean. Again, SPSS or some other statistical software package that you may use, such as SAS, they make it real easy on you to understand the output. So it's clear what the mean is for these two variables. Now, exercise 3, how does the mean, median, and mode compare for blood pressure and for exercise? So go ahead and shut off the video if you haven't written down your answers. Otherwise, I'm going to go ahead and discuss them. So if you look in the box, you see that the mean for blood pressure is 10.1250 and 11.25. The median is 7.0, and for exercise it's 10.5, and then the mode is 1. So if you look at each cell has a valid 1, which means that each outcome is the mode. In other words, everything that was entered into the data, each one just had a frequency of 1. So that's why every item here is part of the mode. But the median, we would do the 50th percentile. So if you calculate the median, what you would do is you would write each of these. So we got the, we have 1, 3, whoops. So if you were trying to calculate the median, you have 1, 3, 4, 5, 9, 16, 18, and 25. Let me make sure I have all those numbers. So we got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I did them all. Let me make this a little bigger for you. So in order to calculate the median, remember it's the 50th percentile. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait, we have 1, 2, 3, 4, 5, 6, 7, 8. So it would be the fourth. 1, 2, 3, 4. Let's underline that. And 1, 2, 3, 4. So we would take 5 plus 9, which is 14, and divide it by 2, and so the median would equal 7. Okay? Now, in contrast to that, if we were doing the mean, we would add all of these up and then divide by 8, because we have 8 numbers there. That's how we would get the mean rather than the median. And again, the mode is all of them because each one of the frequencies is listed as 1. If, let's say there were 3 of them, let's say we had 3 3s instead of 1 and everyone else was 1, then 3 would end up being the mode, but we don't have that there. Okay, let's move on to the next one, which is calculating the median of exercise. So go ahead and take a few minutes to see how that works, and let's see what you get. So if you do what we did before, again, you're calculating these numbers here. So you'd have 1, 3, 6, 9, 12, 16, 18, 25. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 numbers again. Okay, so you have 1, 3, 6, 9, 12, 16, 18, 25. You got 8 numbers, so you're going 4 again. 1, 2, 3, 4. So you got 9. And you got 12 that are the two middle numbers. So you're going to add those together, and that's 21. And you divide by 2, and so it's 10.5 for the median for exercise. All right, so let's move on to standard deviations. I am on page 7 now. So if you haven't defined standard deviation, go ahead and shut the video off because I'm going to go ahead and talk about the answer. So the standard deviation is the amount of variability around the mean. So here, when we ask what is the standard deviation of blood pressure and exercise, we see here, because again, the statistical software packages make it easy for you to read such information. So we know that the standard deviation of blood pressure is 8.59 and of exercise, it's 8.137. So what does that say to us? If we look at blood pressure here, and because here's all the spread of the numbers, we can see it goes from 1 to 25. Okay, so we see the standard deviation for blood pressure, and what that's showing us there is that there's quite a bit of variability between and among these scores here for blood pressure. So that means in comparison to the mean, there is a lot of movement, a lot of variability. It's not that all the numbers are circling around the mean. So the standard deviation looks at the amount of variability around the mean. Okay, so let's try the next group of tests, which is the t-test. So again, without looking at your notes, write down, what does a t-test do? What is it looking at? So go ahead and shut the video off if you need to. Otherwise, I'm going to go ahead and say the answer. So a t-test is a statistical procedure used to compare the mean scores between two groups. Okay, that's key to remember, that it's looking at the mean score between two groups. So for example, if we were doing a training workshop and we wanted to measure the success of that training workshop to see if any change occurred from the pre, which is as the students just entered, and then we deliver the training, and then we measure post, let's say post knowledge, so we're measuring pre-knowledge and post knowledge, for example, we would run a t-test. So go ahead and look at those three output boxes below and answer the three questions. So you're going to answer, first question is, what is the t-test in the outputs comparing? So what are the variables that it's looking at? What is the mean of each variable? And is the t-test statistically significant, and how do you know? So go ahead and shut the video off if you need to, otherwise I'm going to review the answers. So at looking in the three boxes collectively, we know that the t-test is measuring pre-knowledge versus post-knowledge. And the mean of each variable is that the pre-knowledge scores of the group was 5.25, and the post-knowledge scores of the group is 7.62 or 7.63 if you raise up the 5. So we also know that there were 8 people that were involved in this t-test. Is the t-test statistically significant, and how do we know? The t-test is not statistically significant, and we have to look here to see, and we see that 0.112 is greater than 0.05, which means that it's not statistically significant. That means that even though this post score is higher than the pre, that change is really just random error. It's a chance happening. It's not due to the training intervention. So this t-test confirms that our training workshop was not effective in changing the group scores from entering the workshop to exiting the workshop. Now that you've finished practice 1, we are moving on to practice 2. And we're going to have one more application of the module information that you just learned. So if we look at the first exercise, it's asking you to look at the correlation box, and you want to answer these 7 questions. So go ahead and turn the video off, answer those 7 questions, and then come back and we're going to debrief on the answers. So the first question says, what is the correlation in the output box above? And so you should have written 0.939, or if you round it up, 0.94. The second question, is it statistically significant? Well, as we indicated before, SPSS is actually kind enough to tell you if something's statistically significant by adding those little asterisks. So we know it is, but even more important is this number, 0.001, which is less than 0.05. So we know that the correlation is statistically significant. Question 3, is the correlation high, medium, or low? Well, a 0.93 or a 0.94 if you round up is closer to 1.0 than it is to 0. So we know that it's a high correlation. Is the correlation positive or negative? Well, we don't see a negative sign, so we know that it's a positive relationship, which means as one variable goes up, so does the other. Or if one variable goes down, so does the other. So in this case, we're looking at pre-skills versus on-the-job behavior. And so as pre-skills go up, on-the-job behavior would go up. If pre-skills go down, on-the-job behavior goes down. The fifth question asks, what is the mean of pre-skills and of not on-the-job behavior? And so this box tells us that. We got a mean of 5.37, or if we round up, 5.38 for pre-skills, and 8.875 for on-the-job behavior. What is the standard deviation of each variable? And we see the standard deviation for each located there. Finally, how would you describe the relationship, or describe the standard deviation for each? And we can see that if this is the mean and it's only moving by 2, there's some variability, but not a lot. So now we're going to move on to one more practice with the t-test and statistical significance. So you want to look at these output boxes here, and then you want to answer these two questions. So go ahead and do that, shut the video off, and then come back and get a debrief. Okay, so the question says, what is the t-test comparing? And if we look here again, we know that it's looking at pre-skills in comparison to on-the-job behavior. Is the t-test statistically significant? And we would look here for that, and it's 0.000, which is less than 0.05. So yes, this t-test is statistically significant. And that's it for this lesson. So you've learned the 5 fundamental statistical tools, and you've learned to read statistical output sheets. Now that you've enhanced your knowledge and skills in basic statistics, Module 3 will educate you about 2 more important research tools, and that deals with validity and reliability.